Okay, let's take a look at definition of logarithms. It says if b and n are positive numbers where b does not equal 1, then the log base b of n is equal to k, if and only if b to the k power is equal to n. So we're looking at converting from logarithmic form to exponential and back and forth. That's what if and only if means, going forwards and going backwards. Now notice that b and n are positive numbers. If you'll remember from yesterday's claw, when n was negative, we got a non-real answer, okay, because n needs to be a positive number. Also, b cannot be equal to 1 down here. Okay, so looking at exponential form, going from exponential form to logarithmic. So we know that 2 to the third power is equal to 8. So converting that to logarithmic form, remember that this represents your base. So the base goes here. Okay, and then remember that an exponent represents, a logarithm represents an exponent. A logarithm represents an exponent. So that means that this is going to be the exponent, which is 3. Okay, and then the 8, the answer to the exponent problem, is your argument. So you just need to know placement. The base will go here, the exponent will go here, and then the 8 will go in the argument spot. It kind of goes in a circular pattern. First number, then the argument, then the exponent. Okay, so 2 to the 4th power, we know that 2 to the 4th power is 2 times 2 times 2 times 2, which is 4, 8, 16. Okay, so 2 goes in the base, okay, going in that circular motion. 16 is going to represent the argument, okay, and then 4 is the answer. So log base 2 of 16 is equal to 4. In other words, 2 to the 4th power is 16. Again, there's that circular motion. 2 to the 3rd power is equal to 8. Okay, we know this rule from exponents. 2 to the 0 power is, that's right, 1. So going in that circular motion, 2 is the base, 1 is going to be our argument, and 0 is going to be our exponent or our answer to our logarithm. Okay, continuing on. Here we know that 2 to the negative 1 power is 1/2. Okay, so 2 is our base, and so 2 would go here. So this, converting from exponential to logarithmic. Again, circular pattern, 2 to the negative 1 power is equal to 1/2. That's what we have right here. 2 to the negative 1 power equals 1/2. Okay, so here we have some number raised to the 1/2 power is equal to 4, is equal to 2. And so we know that the 1/2 power is the square root, hopefully, right? So we know that the square root of 4 is equal to 2. Means log base 4 to the 1/2 power, log base 4 of 2 is equal to 1/2. Okay? Alright, so here we're using letters. So 2 to some exponent is going to be equal to some number. Okay, so 2 log base 2 of n is going to be equal to whatever that exponent is. Remember, a logarithm represents what? An exponent. Okay, it says write each equation in the other form. So, following that circular path, starting off with our base, okay, that's our base. Remember that 4 is our exponent, and that's going to be equal to the argument. You know you did it right if this makes sense. Okay, so I will let you do number 2. Now here we're going from exponential to log. So of course we're going to write down the log, and of course we're going to start off with the base. And going in that circular pattern, 64 will be our argument. And of course a logarithm represents a exponent, and our exponent is 2. Pretty easy, right? Just need to know the placement of the numbers. You go ahead and do number 4. Alright, evaluating. Alright, we get to evaluate this. It says evaluate the following logarithms without using a calculator. So no change of base here. No change of base. We're going to go ahead and first of all, it's in logarithmic form, okay? So we're going to write a little equation. So we're going to start off by writing 5, okay? Raised to the, we don't know, right? So we're going to make this a variable because that's what we're trying to find. We're trying to find this answer here. And that's going to be equal to our argument. So 5 to the x power is equal to 25. And then we just use what we've already learned to solve for x. We're going to, since we can make both of these base 5, yes? So x equals 2. Okay? So, why don't you try number 7? Don't do it in your head. I know some of you can figure this out in your head and you got the answer and you can just write it in. I want you to go ahead and write down the exponential equation, make the bases the same, and then get your answer from there. Okay, let's look at number 8. So again, making this into exponential, we start off with the base, raised to the x power, because we do not know the answer, equals negative 16. Well, you know, you should, if you recall the definition, b and n are positive numbers, so that means our argument, okay, can only be positive numbers. So this is going to have a non-real answer, so we'll just put NA, no answer. Unless you can come up with 4 to some number that gives you negative 16, which I don't believe you can. Let me know if you think you can. Okay, let's look at number 9. So 10, okay, starting off with the base, raised to the x, which we don't know, okay, equals, and then we're going to put in our argument. Now our argument is 10 to the third. Okay, equals 10 to the third power. Simple. Bases are the same, x equals 3. So 10 to the third equals 10 to the third. Alright, let's do a few more here. We got 3 raised to the x equals 1/3. Okay, we want to make the bases the same, so let's make both bases 3. So this will stay 3 to the x, and we need to move that to the numerator. So recall that the exponent changes sign when you move it, so that would be 3 to the negative 1. So the bases are the same, x equals negative 1. Alright, why don't you try number 11? And let's do number 12 real quick here. 16 to the x equals 1/2. 16 changes to 2 to the 4th. And move 2 to the numerator, that's 2 to the -1. So what do we have here? We have 2 to the 4x equals 2 to the -1. Cancel out my bases. 4x equals -1. Divide by 4. X equals -1/4. And there you go. All right, quiz time. Once you're finished with your quiz, then you'll work on the claw for this assignment.